Assalamualaikum and hi, my name is Kecerdasan binti Muhammad. My matrix number is BT12703. So I'll be presenting part 1, which is construct appropriate graphs or charts to compare the relative frequency and cumulative relative frequency in each dataset. The formula to find relative frequency is class frequency divided by the total number of observations, while the formula to find the cumulative relative frequency, I'll be explaining it in the next slide for you guys to get a clear view of it. So I had put the data into classes to get answer for relative frequency and also for the cumulative relative frequency. For relative frequency, I divide the frequency by the total number of these data values, which is 24. And for the cumulative relative frequency, I add the previous relative frequency to the relative frequency for this current row. Next, for the graph, I use histogram to present the relative frequency, and I use GIF to present the cumulative relative frequency. As you guys can see from the graph, the relative frequency shows decreasing, while the cumulative relative frequency for the domestic is increased. Next is for international. This is the value that I got for international. This is the graph for international. I use the same graph also with the domestic. So for the graph of international's relative frequency, it shows the value inconsistency, which is the value are decreased at first, then it's increased, and finally it's decreased. While the cumulative relative frequency graph for the internationals are increasing.
My name is Camelia binti Yahya. My matrix number is BB22110012. Next, for part 2, calculate and compare measure of central location in each dataset. First, we are going to look at sample mean, which is x bar equal to sum of observation divided by sample size. So this is the data for domestic airlines, the total sum divided by 24, which is the total number of observation. For comparison, the international airlines is higher than domestic airlines as digitalization has impacted more on travelers from international. For median, we have to arrange the data in ascending order and divide it by 2. For domestic airline, we get 217,716. Meanwhile, for international airlines is 137,048.5. In comparison, domestic is higher than international. For mode, this data set has no mode because there is no frequent occurring value.
I'm Analitik. My matrix number is BB22110573. Part 3 will be calculating percentiles and construct box plot in each dataset. To calculate percentiles, we will be using the formula LP equals bracket n plus 1 bracket times P over 100. Next, box plot will be displaying 5 summary values, which are the maximum value, minimum value, first quartile, median, and third quartile. The box plot shown in the slide is sorted by using the domestic airline data, which shows the maximum value as 4,269,181, minimum value as 37,312, first quartile as 141,202, median as 217,716, and third quartile as 676,874.5. The next box plot is sorted by using the international airline data, which shows the maximum value as 8,808,742, minimum value as 52,937, first quartile as 93,787, median as 137,048.5, and third quartile as 165,069.5.
I'm Tracy Anababa and my matrix number is BB22110845. And I'm going to present part 4, calculate and compare measures of the percent in each dataset. First of all, range. Total range for domestic is 4,231,869. And total range for international is 8,755,805. The sum of the absolute value x minus x bar n divided by the number of the sample. As you can see on this domestic table, The mean deviation is 275609971831.76. This one is international table. This shows that the international mean deviation is higher than domestic mean deviation. Secondly, variance and standard deviation. The standard deviation for domestic is 987,952.8785, and standard deviation for international is 1,940,297.633. For coefficient of variance is just take the standard deviation and divide it by mean.
My name is Perniagaan and my matrix number is BB22101 and 42. I am taking part 5, which is calculate and interpret measure of association. In this part, I will be calculating the covariance and the correlation of this data. So the first one, we will be looking into covariance. The formula is sum of x minus x bar and y minus y bar divided by n minus 1. The summation of x minus x bar and y minus y bar is 340,129,763.07.10 divided by 24 minus 1, which is 23, and the final answer will be 147,882,564,448.13. Next, I will be calculating the correlation. The formula is covariance divided by standard deviation of x and standard deviation for y. The value we can simply take it from the previous question, which is 147,882,564,448.13 and divided by 987,952.8785 and 1,940,297.633, which we can get it from the previous part. We should multiply the standard deviation for x and y first before we divided the covariance to the answer of it. So the final answer will be 0.76. This values shows a positive relationship between the variable x and y, and the strength of the correlation is strong because it is closer to 1.